So, hello guys. Today I'm going to explain the time independent Schrodinger equation. So, we are taking time dependent Schrodinger equation as a reference, and with the help of time dependent Schrodinger equation, I'm going to explain our proof of the time independent Schrodinger equations. So, time so on the from the time dependent Schrodinger equation, which is such that h cut square 2m del square psi x comma t plus bx psi x equal to I h cut del psi function of x and t over del t. This is the time dependent Schrodinger equation. Here function is of x and t. So uh, solve this equation, we have to separate the variable. So we are taking uh, psi x, separate function of x and t. So phi x into f of function of t. Putting these value in the equation, here del square is a Laplacian operator. So if we put these two values, the multiplication of those two function, so the function of t will be come out for from this operator, because here the Laplacian operator only function of x. So what will be the next step? Minus h cut square 2m f of t del square phi of x plus bx phi x into function of t equal to, here the partial differentiation with respect to t. So the phi of x will be come out from this partial differentiation. So IH cut FT, sorry, it will be it will be like phi of x into this. So now dividing this equation by this, now this equation y phi of x and function of t. So what will be the next step? Here it will be cancelled out. So h cut square upon 2m phi of x plus vx. Here both the function will be cancelled out, and here psi x will be cancelled out. So what will the final ih cut upon ft into upon del t. So here we got the function of x, and here we got the function of t. Actually we got the separate variables on each side, so we can common here 5x plus vx into 5x h cut. So we got this value. So here both are equal, so we can consider a constant let, which is equation number 3. Now solve these both sides with the help of g. So what will be the next steps? So we take ih cut g. So phi h cut del phi over equal to g into function of t, or equal to 1 upon ih cut g function of g into function of f of t. So we can take I denominator, so del t minus I upon h cut d into f of t. On solving this equation, we got the f of t equal to e to the power minus ig upon h cut into t. Can take it equation number what we'll take in the previous slide. I think it would be equation number 1. 3 plus 1 and 4. So we got the solution of ft from here. We can solve here also. On what is the formula of e to the minus ix is equal to cos ix minus I sin x. Okay, so uh, this will be the x, so cos g upon h cut into t minus I sin vt upon h cut we can write uh, cos 2 pi g upon h, because it will not change the value of sin gst by h cut. Okay, oh sorry, here we replace uh, h cut by h. So in next step, what will be the value of ft cos 2 pi mu t I sin pi mu t, where mu equal to v upon h. Because here dimension of the g is equal to h in m, which is dimension having equal to energy. So we can replace g by e. So now ft will be minus I et upon h cut. Okay, this will be the value of ft. And the other part we can consider what we have considered uh, square upon 2m del square pi x b is equal to g. We can write it equation number 5. In previous slide we had proved that g is basically is a energy term, so we can replace it g by e and it will go in the multiply of g, basically multiply of e. So this will be equation number 6, which is basically time independent, which is basically a time independent Schrodinger equation. Here we have proved the time independent Schrodinger equation with the help of dependent Schrodinger equation. Thank you.